Did you know that starting this year, 2025, you are required to know the exact trigonometric values of certain angles? You didn't know that? Not to worry, I've got you covered. You're welcome to my YouTube channel. Thank you for stopping by. Today, I'm going to teach you how to find the exact trig values of certain angles without you needing to memorize it. All you need to remember to draw is a triangle, a unit triangle. Now, the very first triangle I have drawn here is this isosceles right angle triangle. Let's break that down. This triangle is definitely a right angle. How do we know that? This box in the corner here shows that this triangle is a right angle triangle. I said it is an isosceles right angle triangle because the two sides are equal. These two sides are equal. They are both 1 unit apiece. And this is the hypotenuse here. Now, if the two sides are equally 1, we can find the hypotenuse using the Pythagoras theorem. If you use your Pythagoras theorem, you're going to find out that the hypotenuse will turn out to be the square root of 2. All right, now that we have been able to identify all the sides of the triangle using Pythagoras theorem, we need to remind ourselves that since this is an isosceles triangle, then both angles here will be 45s. Why are they 45 degrees? Because if this is 90 and the other two should be equal, the sum of angles in a triangle is 180, so these two should be 45 apiece. With this in mind, we can now find the cosine of angle 45, the sine of angle 45, and the tan of angle 45. To do this effectively, we need to remind ourselves this acronym we use to find sine, cosine, and tangent of angles in a right angle triangle. Remember the acronym? It is SO, CA, TOA. What does this mean? It means that when you need to find the sine of any angle, all you need to do is the opposite over the hypotenuse. Whereas when you need to find the cosine of the angle, you need to find the adjacent over the hypotenuse. And finally, to find the tangent of an angle, you need to say it is the opposite over the adjacent. Now, we could choose any of the 45 degrees, and I'm choosing to use the one right here, this one. As far as this angle 45 is concerned, this is its opposite and this is its adjacent. To find out more about this, I have a video on how to label and name your triangles properly. Please ensure you check out that video. Now, to find the cosine of this angle here, we remember that from this, it says CA, that is adjacent over hypotenuse. What is the side adjacent? This, it is 1, and the hypotenuse here is root 2. So the cosine of angle 45 is 1 over root 2, which could also be written as root 2 over 2 if we rationalize our denominator. Confused? Please don't be. Rationalization is what we do to the denominators of surds to make them real numbers. Remember, surds are, to make them rational numbers. Remember, surds are irrational. So to make them, the denominators rational, we rationalize the denominator. I also have a video on that. Please check it out. Now, let's go on to the sine of angle 45. Again, this same angle. Sine is what? So that is opposite over hypotenuse. Opposite this is 1 divided by its hypotenuse, which is still root 2. So the sine of angle 45 is given by 1 over root 2, which can also be written as root 2 over 2. Finally, we have the tangent. The tangent of the angle is given by opposite over adjacent. Opposite is 1 over its adjacent, which is also 1. That means the tangent of angle 45 is 1. Now we are done with angle 45. Let's move over to looking at another triangle. This time around, I have drawn an equilateral triangle. What makes a triangle equilateral? It means that all the angles are equally what? 60 degrees. And this time around, we have chosen to label the sides having a length of 2 units. So if this is this is an equilateral triangle and all the sides are 2 units, if we break it down the middle, this angle remains 60, while this angle up here becomes 30 degrees. Again, by Pythagoras theorem, this side here is going to be root 3. Now that we know all the sides of this right angle triangle, we can then proceed to finding the cosine of angle 30. This is our angle 30 here. Remember from our SOHCAHTOA, the cosine of any angle is given by its adjacent over its hypotenuse. Here, the adjacent is square root of 3 divided by the hypotenuse, which is 2. The sine of any angle is given by the opposite, 1, divided by the hypotenuse, which is 2. In the same vein, the tangent of any angle is given by its opposite divided by its adjacent. As far as angle 30 is concerned, this is opposite and root 3 is its adjacent. And 30 will be given by 1 over root 3, which is the same thing as root 3 over 3. Also, we need to look at our angle 60 now. For angle 60, which is right here, to find the cosine of angle 60 will be adjacent over hypotenuse, that is 1 over 2. The sine of angle 60 is given by opposite over hypotenuse, which is root 3 over 2. And finally, the tangent of angle 60 is given by what? Opposite over adjacent, which is 1. So the tangent of 60 is given by root 3. Now, if you pay close attention to this, you will notice there are similarities that you can use to remember this. But not to worry, if you don't remember in the exam, or quickly draw your triangle and find out this angle. I hope this was helpful. See you in the next video. Have you subscribed yet? Oh my, what are you waiting for? Please subscribe so you don't miss subsequent videos where we'll be solving questions on trigonometry. See you in the next one. Bye.